Society stands at a unique and crucial point in human history. We have reached a crossroads where our actions will decide our future. The global health emergency has shocked the world, placing extra pressure on lives, livelihoods, and the economy. But in this moment of crisis, we are presented with a once-in-a-generation opportunity to create a better world. Our work as a modern regulator and as an environmental leader will protect and enhance the environment and the places where people live, work, and play. We want to leave the natural environment in a better state for future generations. We are proud to inspire and empower the environmental guardians of the future. The Environment Agency, we work to create better places for everyone.
Hi everyone, my name is Kelly Fisher. I'm a Flood and Coastal Risk Management Senior Advisor working for the Environment Agency, and we're here today to present to you about climate change and the coast.
Hi everyone, I'm Guy Cooper and I work with Kelly at the Environment Agency. I'm a team leader in our area incident team and have a long-term interest in our dynamic coast and the communities at risk there.
So first up, let's think a little bit about climate change. Now, the Earth formed around 4.5 billion years ago, and the global climate has been changing since the Earth formed, and it will continue to change into the future as well. Now, scientists believe that since the mid-1800s, human activity began influencing the climate due to the burning of fossil fuels like coal and oil.
Fossil fuels include coal, peat, gas and oil, and these are all formed from fossilised, buried remains of plants and animals that lived millions of years ago. When fossil fuels are burned, they release large amounts of carbon dioxide, and this is a greenhouse gas. And when they release it into the air, and that traps heat in our atmosphere, which can cause global warming and elevation in the temperatures around the globe. Since around 1950, there's been a dramatic increase in global temperatures.
Now, due to those increases in global temperatures, let's think about the possible impacts of climate change. Now, those impacts might include stronger tropical storms and hurricanes worldwide, an increase in extreme weather events, increased droughts and pressure on water supplies. Species in affected areas could even become extinct. Glacier retreat and melting of sea ice in the Arctic, as well as rising sea levels. Now, due to these impacts, climate change is linked with an increase in natural hazards, particularly at the coast. So let's take a closer look at that.
So let's have a quick look at tropical storms and hurricanes. Tropical storms and hurricanes form at sea, and they have the greatest impact at the coast where they make landfall. Warmer air and water temperatures are likely to cause stronger tropical storms worldwide as a result of them holding more heat energy. Now, warmer air temperatures can hold more water vapour, increasing rainfall, and warmer sea surface temperatures intensify wind speeds, and this can create large destructive waves accompanying those strong damaging winds. Over time, in combination with sea level rise, this is likely to cause increased coastal flooding.
Let's think about drought and saltwater intrusion. Warmer global temperatures lead to a higher likelihood of drought, which means water supply shortages, intrusion at the coast. Now, drought causes increased pressure on water supplies, which could result in more instances of saltwater intrusion. Saltwater intrusion is the contamination of fresh water supplies stored in underground rocks with saltwater. This can be caused by groundwater pumping near the coast, which pulls the saltwater into the underground rocks, a bit like a sponge.
Now let's have a look at the possible impacts on species. So species in affected areas could well become extinct, and there are impacts on our health and well-being too. Droughts and storms, heat waves, saltwater intrusion as Kelly was describing, and rising sea levels along with melting glaciers and warming seas all have their impacts on wildlife and people. These impacts can negatively affect food and water resources, destroy habitats and make living conditions too difficult for survival. When people's livelihoods, safety and communities are impacted, this can lead to poor health and spread of disease.
Something that's really important to think about at the coast are the potential impacts of sea level rise. Now, sea level rise is caused by global warming, and that's because the added water from glaciers and melting sea ice is causing sea levels to rise. As seawater warms, it expands, and this leads to sea level rise as well. And that's because as water warms, its molecules gain energy and move faster, causing an increase in water volume. Now, a rise in sea levels result in a greater risk of coastal flooding and erosion as well. It is predicted that sea level rise will affect 80 million people globally.
So let's have a closer look at coastal flooding and erosion. Erosion of cliffs and flooding from the sea are naturally occurring coastal risks. And coastal management can help us to adapt to changes in this risk and reduce them. An increase in extreme weather can also contribute to flooding and erosion. Stronger winds cause larger waves, which can erode coastal sediment away, but also overtop flood risk management structures such as seawalls and embankments much more frequently. In some low-lying areas like the east of England, land levels are still adjusting their sinking as a result of the effects of the last glaciation, or ice age. And this means that sea level rise will have a greater effect in these places, and coastal flooding is more likely.
Now that we've learnt about some of the impacts of climate change, how can we adapt to those changes at the coast? Well, coastal management can help us out. There's a few options available. We have monitoring or warning systems. Coastal flooding can be predicted in a similar way to weather forecasting and monitored through water level gauges. People can then prepare for flooding or storms and be evacuated if necessary. We also have the option of hard engineering. Now that means flood and erosion risk management structures. Physical structures can protect cliffs or communities by dissipating wave energy, encouraging deposition by reducing wave energy, or helping stop transportation by trapping sediment. Structures can also act as a barrier to seawater. Lastly, we can work with natural processes, and that's called soft engineering. Restoring natural sand dunes or salt marsh can dissipate wave energy and restore habitat for wildlife or plants. And beach sediment can also be replaced by importing sediment, either from elsewhere along the coast or from the seabed.
In some cases, we may not be able to build structures or work with natural processes as Kelly described to adapt to flood or erosion risk. And this is because physical structures are expensive to build and maintain, and they're not suitable everywhere. Sometimes structures can disrupt the transportation of sediment to other parts of the coast, and that can cause problems elsewhere. So we can look at rollback and relocation. We may be able to relocate or roll back homes away from risk, either physically or through the planning permission process. And where we aren't able to relocate property, we can look at resilience, where we may be able to adapt buildings to ensure people can recover quickly following a flood. And these buildings are called flood resilient. We could also build new houses which are elevated or even on stilts to keep them out of flood risk.
So we've thought a little bit about climate change and the coast. We now understand some of the impacts of climate change, including sea level rise and increased storminess. And we also understand how that could lead to more erosion and flooding at our coast. And then we've had a think about how coastal management can help us adapt and manage those risks. Now we're going to put you in control. And the Sea Level Rise Challenge puts coastal engineering in a lunchbox for you. So we're going to use this simple kit to try out different ways to reduce flood risk to your homes and then see what difference sea level rise might make to the resilience of your homes. There really are no limits other than your imagination. So let's take a look at a video.
Welcome to the Coast Near Sea Level Rise Challenge Kit. This simple kit allows you to explore some of the potential problems of sea level rise around the UK and ways we can use to try to manage that risk. So here's what you will need for your sea level rise kit. Now you can use materials that you've already got around the home or that you can buy easily. And first you need a long plastic box that's reusable so you can use it after the experiment. This needs to be about 30 centimetres long so that you can generate waves and still have your landscape, but also no more than 15 to 18 centimetres wide. You don't want it too big. It should be 5 to 6 centimeters deep. That's all you'll need for your experiment. Then, in order to make your engineered structures, you'll need some modelling clay, like plasticine. Now, it's useful to have different colours, so you can pick out different features in your engineered structures, like embankments or sea walls. The next thing you'll need are your homes or businesses, and these can be made of paper. There's a template in the Coastneers instruction booklet to get you started. They're just folded up and sellotaped together, and it's important that they're paper, so that when they're flooded you can see that they're damaged. Now you can use lots of other materials, but paper straws will be particularly useful for some of your resilience measures you might put in place to protect your homes and make them more resilient. Then you need a lid from another box that fits just inside yours to generate the waves, so this is your wave paddle. And finally, you'll need your sea, so you can use normal tap water, just coloured blue with watercolour paint, and that can be your seawater. So now let's have a look at some of the impacts of sea level rise. In our kit, we've used some of the modelling clay to build an embankment, designed to today's sea levels, and a different colour modelling clay for our landscape, and you'll need this to push some of the features in you might design later to make your homes more flood resilient. Now let's add some seawater. Add about 1 centimetre of water to your box to replicate today's sea levels.
So you should find you have something that looks a bit like this. So in your lunchbox, you'll have some clay as a ground to put your resilient features in, your paper homes, some sort of structure like a clay embankment, and then your water, which you can use to test how your embankment works.
Now, this is why you use 2/3 of your box for the water, so you can generate waves.
Now let's put our properties in the floodplain behind. And you can see the waves just lapping up on the embankment there, but they're being mostly kept out, and the properties behind are staying dry. Now let's add some more water to simulate sea level rise. So we can show a metre of sea level perhaps with a centimetre in the box. Using your wave paddle, you can generate exactly the same waves that you did before, so the same level of storm but with a higher sea. And you can see the embankment's being overtopped and the floodplain is flooding. Those properties are very definitely being damaged now by that floodwater. So what we expect to see with sea level rise is that the same level of embankments we have now could become overtopped more frequently, leading to deeper and more frequent flooding in the floodplain and more damage to people's homes. Now let's keep adding more water. Can you describe what you can see? From this side angle, you can see that as you add more water and the sea becomes deeper, when you apply the same wave action, so the same strength of storm, it starts to overtop that embankment almost immediately and collect in the floodplain behind. So not only is it damaging those properties, but it's leaving lots of floodwater behind that embankment as well, and this may need to be pumped or drained away afterwards. How can we reduce these impacts? You could try different structures. You should set a limit for the height of the structures or defences that you build to no more than 2/3 of the total box height. Flood risk management structures are expensive to build and maintain, and homes are more desirable with a sea view. It's not always possible to engineer infinitely high defences. Here's an example of an engineered structure where, instead of an embankment, we have a straight wall with a wave recurve on top. It's a simple curved concrete section, and it acts by returning the wave energy back out to sea, as you'll see as we demonstrate. So let's generate those waves. Can you see those waves being returned back out to sea by that wave recurve? It's really quite effective. None of that water is going over the wall and flooding the properties behind. We can have a look from the side as well, and you should see those waves going up the wall and being returned back out to sea by that wave recurve feature, leaving the homes behind quite dry and safe. We could try making the houses behind the embankment more resilient to flooding. Here's an example that you see around the coast. These homes have been put on stilts, so they've been raised up out of the flood level in the floodplain. As we start to generate those waves, you can see the embankment is being overtopped and the floodplain is being flooded behind, but the homes stay undamaged. And this is one way that communities can live by the coast and be more resilient to flooding. Let's have a look from the side. From the side you can see as those waves overtop, it starts to fill up the floodplain. But those houses are raised up on those stilts made of your paper straws above the level of the floodwater, and so the houses stay quite safe. Can you think of any problems with this though? It might not be great to be surrounded by floodwater for a long time, even if your house is safe. We see real examples of this around our coast. Here's a house on stilts at Seawick in Essex. So, what else could you try? Here's a few ideas to get you started. You might try simulating wetlands like salt marsh to see how that breaks up the wave energy in your kit. You could use Lego with plasticine to make a blockwork wall and see how the waves crash against that. You might use your modelling clay to simulate a beach and see how the waves move up the gentle slope of a healthy beach. And on that beach, you could add wooden structures like revetment and just see if that does anything to break up the wave energy. You could even get inventive with pasta to make blocks to break up the waves, and you do see structures similar to this on our coast for just that purpose. You could use stones to simulate rock armour and see what that does to the wave energy as it comes up against the embankment. Or maybe we could adapt in future and try to move away from living permanently in the floodplain. With each idea, describe what you can see and think about the positives and negatives.
So we really hope you came up with some fantastic ideas to help you adapt to sea level rise. Let's take a look at some of the options that we came up with. Well, we put some soft engineering in. You can see we've got some moss there, and that shows natural flood management. You can also see that we put some homes on stilts. Look at the wave coming over the embankment there. That's not going to affect those homes. We put some rock armour in front of a wall to help dissipate wave energy. We also put a simple blockwork wall up to stop floodwater from overtopping. And then we thought, why not just don't build in the floodplain? Build somewhere else, roll back, relocate your houses. That's a really clever idea. We got inventive with pasta to make blocks to break up the waves. And we put in wooden structures like revetments to help dissipate wave energy. And then lastly, we added a beach because there's nothing like a beach as a natural feature to help really dissipate and calm that wave energy. So we're really excited to see what you've come up with.
So look at what you did and think about, would that be a good long-term solution? Could it interrupt people's view or access to the beach? Is it good for wildlife? Would it be expensive to build and maintain? Have a think about what you did to adapt, and have a think about some of the advantages and disadvantages of your approach.
We really hope you enjoyed adapting to sea level rise with our Sea Level Rise Challenge kit today. But lastly, we just wanted to talk to you about careers at the Environment Agency, because it's not just about engineering structures. We also have planners and geographers, ecologists and biologists, geographical information specialists that work with maps, environmental scientists, flood modellers, as well as coastal and flood risk engineers.
And as well as those careers at the Environment Agency, we also have an incident response role. So we have over 6,500 colleagues that are trained and ready to respond to flooding incidents. We don't always know when these will occur, but we have a forecasting system that gives us a few days to prepare. And these colleagues may be involved in flood warning activities or operating some of the structures we've talked about to try and reduce the flood risk to communities. It's a really exciting part of the role that we do.
Thank you for joining us today. My name is Taz Jagdev, and I'm a Programme Manager here at the Environment Agency. I really hope you've enjoyed finding out about the range of work that we do, and I'd like to leave you with a couple of questions to think about. So, what are you going to do to protect our environment? With the threat of the climate emergency, there's never been a more important time to take action. And what do you want to do in your future? It's a challenge to find a career which really suits you. Here at the Environment Agency, the different work we do means we have a job for everyone. We value you for what you have to offer. We need your own unique skills, experiences, and personality to help us tackle the biggest environmental challenges we face today. After all, that's how we can work together and build towards a brighter, greener future.